Welcome to the Crazy Wisdom Podcast. My guest today is Marcin Dumczyk, and he is the CPO and co-founder at 7sense Robotics. Welcome to the show.
Hello, Stuart. Very nice to meet you, and thanks for having me here.
Yep. We're going to have so much to talk about robotics. I just learned about Poland. I know that Poland increased their exports from China of robotics by 7,000% this year. And they're the leader outside of Vietnam, Mexico, and a few other places. What originally got you into robotics?
Yeah, that's a great question. So I was thinking about it even when writing a bio note about me for the podcast, and I think it comes a bit from my parents and my initial interest as a child. So on one hand, so my mom is like an active academic in the technical field, so she always took me to the university, showed me things. It was mostly about like high voltage and electricity, but still, like I was like touching some random electron microscopes on kind of a room next to hers and stuff like this. While on the other hand, my father, he's also super interested in technology. He like has this like super like wide knowledge about pretty much anything technical, right? So he did electronics and microwave communications and mechanical engineering. So he was trained as an basically aerospace engineer, back in communist Poland, and he got this magic knowledge that I'm like still absolutely impressed by, because he can answer pretty much any question. And so we did a lot of things together with him, right? Like disassembled devices, looked how things work already as a few-year-old. And this somehow started the passion for moving things, for technical things, for building things.
Very cool. We could go on a tangent about sort of Polish and Soviet science, which has always really interests me because the Soviets had a great education system. And there's a lot of like Western thinkers who are very contrarian and go and mine all the details inside of Russian, what the Russians were doing. My most interesting fact I learned recently is that, well, the Soviets and the United States did start to collaborate together on Apollo missions in like the 1970s or 1980s, I think. And then at one point, this crazy Russian scientist wanted to put a mirror in space and then reflect the sun so that they could bring summer to the northern hemisphere. And so they tried one, failed one, and then but then in the 90s, after the Soviet Union fell, they actually did a successful one, and then it like beamed the sun. And it was like a really, like a really like bright light, like a moon or something like that. That's what it looked like to people, and it's just like totally crazy. So there's a lot of crazy stuff that was going on that I don't think the West really has understood.
Absolutely, yeah.
And is that like part of what your father taught you? Is like he was how different was Poland from the rest of the Soviet Union? Was there a large difference between the two?
I would say so. So, I mean, Poland was maybe not the closest to the western side of Europe, right? Or Western world or the US, but it was like somehow closer. So you could definitely, you had a bit more freedom in terms of science, in terms of technology. You had a bit of maybe small elements in 70s and 80s coming of somewhat, let's say, free economy. I mean, it wasn't really free, but you could do a bit of small businesses in the 80s. So it was, I would say it was a bit better, right? You also have plenty of Polish people in the US, right? Like Chicago being one of the hotspots. So this kind of context with Polish people in the US somehow brought a bit of also scientific context and research collaborations together with Western world. But I think like many things for the Soviet science, for Soviet technology still remain true, right? That the means were limited, money was limited, you couldn't like source equipment. And my thought at some point about it was that instead of using like fancy equipment, right, you had to resort to like a pencil and a notebook, right? And this somewhat brought beautiful things, right? Because it was tough, but also motivated people to do something different, maybe.
And constraints breed creativity type of stuff, more practical. I've been studying science in the West for the last couple of years, and particularly the rise of big science. And big science, like nobody learns about it, nobody teaches it. Maybe inside the universities they do, but like this idea that science was this gentlemanly art before 1920 or 1930, where you had, sort of well-off gentlemen going and tinkering in their lab. And that almost completely disappeared once the atom bomb was invented. And all of a sudden you had the government being like, we got to put a lot of resources into this so we can create our bombs, our viruses, all these things that we've had for the last 100 years. And so very interesting stuff. In Poland, I don't know too much about Poland. I want to know more about Poland. I've been to Szczecin.
Okay.
Very beautiful city. And so, but like, let's dig into this robotics. Well, actually, let's start with your company first. What is your company? What does it do? And did it start in Poland?
Yes. So the company is called 7sense Robotics, and we often say we build the eyes and brains of mobile robots. So it's mostly about bringing the autonomy algorithms that are camera-based, so not LiDAR-based, not something else-based, but camera-based, to mobile robotics in industry or in professional cleaning industry as well. So the company wasn't started in Poland. It was started in Zurich, in Switzerland, where I live right now. And I think you spoke to Kevin some episodes again, who was also like coming from ETH Zurich. So it's 7sense was yet another spin-off from ETH Zurich. And I can say it's pretty common. So Zurich is becoming a bit of a hotspot of advanced robotics technology. And the local universities are producing plenty of companies, focusing on different sides of robotics, from software through drones, also touching humanoids now, but also mobile robotics, as we did some years ago.
Because there is a humanoid company from Poland. I remember seeing that. Right, there's a guy. They've created like the Westworld humanoid robot. Have you seen that?
I don't remember the name, but I think I saw it in one of my news feeds or like weekly newsletters. Yeah.
Yeah. Okay, and so let's get into like robotics, and let's give the listeners a sort of 101 on robotics. You said advanced robotics company. That implies that there's sort of a normal robotics and then an advanced robotics. What is normal versus advanced robotics? What is the advanced robotics really focused on?
So it's a tricky question, because 7sense was actually acquired by ABB, which I would call a traditional robotics company not long ago. So I cannot say things which make it too simple to build standard robotics. Yeah. But I mean, in my books, right, like standard robotics for many years was either building manipulator arms for industry or building mobile robotics, which are somewhat, I mean, I don't want to say dumb, but more or less following a very, very rigid definition of their work, right? So you can imagine they were like following the line, stopping at some crossings, picking up some whatever goods at some very well predefined spot, and then going to the also well-defined target spot or goal position. And that works, right, in those workflows or industrial cases where you know exactly how you work up to a second and there are like no unexpected things. But whenever you need a bit more flexibility, a bit more thought, right, where the robots, like, I don't know, the manipulator arm knows what to pick instead of pre-programming the location.
Wow.
Or where a mobile robot knows, okay, I should get there, but I don't care what path I take. I just take whatever path is the fastest and free, right? This is like where somewhat the advanced robotics or intelligence starts. It starts with perception and thinking, right? Or smartness, you could say.
Wow, okay. Lots of questions there. So mobile versus fixed pathways, there's predefined spots. There's just like an arm that goes down and picks something up. That's in the normal, the standard robotics. And then the advanced robotics is more about perception and getting off of sort of linear lines of activation. And you guys got acquired by ABB. Wasn't ABB just acquired or no, invested by SoftBank? Didn't ABB just get an investment from SoftBank or something like that?
That's correct. So the ABB itself, which is like a big Swiss-Swedish group, right, has this one division, which is robotics, which is being spun off right now and actually acquired by SoftBank. So the transaction is somewhat in progress, but this was publicly announced already.
Yeah. Okay. So but ABB was this, sort of standard robotics, but now they're getting into. So it makes me feel like advanced robotics is basically what the AGI of physical robotics is, right?
I would say so, yeah.
This thing that's going to continue to go off into the future, and it's like, oh, we don't have AGI yet, because every time we get to whatever would be considered AGI in the last time, like that's so advanced robotics is. So what are the next? What are the things that are still within advanced robotics?
Hmm. So I think maybe one comment on ABB, right? So
Sure.
I think it's like, so this push towards advanced robotics has happened even before like 7sense and things like that, right? So I think for a number of years, it's kind of clear that the mechatronics problem, like squeezing another, hundredth of an millimeter of precision of how arms move, has limited value, right? At some point, like the value really lies in being smarter than just moving from A to B. So I think that was already clear for our ABB colleagues, also all other companies a long time ago. And if you want to innovate, you innovate already towards this advanced direction. And now my thoughts about maybe this advanced direction is that to actually make robotics somewhat ubiquitous, like popular, right, in different spots, you need to make robotics simpler. So both for mobile robots and both for manipulator arms or whatever, it's like configuring a project to actually work in the industrial case. It takes days, sometimes weeks, sometimes even longer, right? And this is insane. So where I think the modern technologies, AI, AGI will make a difference is to actually, someone having like a mom and pop workshop, right? Like with 10 employees or something, and needing a bit of help to transport material, right? And if this person could, let's say, tell a robot, right, or prompt a robot, hey, I need to transport material from here to here, just figure out your path, figure out how you grasp it. You don't need to program like how exactly it like picks material, right? It would just know, like a human, right? I think that would be like really a qualitative change for robotics.
Okay, very interesting. I like this idea of a mom and pop workshop with 10 employees. I'm going to share an idea that I've been kind of thinking through. So I've been doing a lot of AI generated coding. The AI coding is now so good with Claude Code that I don't really have to think about it anymore. I just come up with an idea. I build the application. I'm not building these applications for other like large teams or consumers or anything like that. So it's not about like the quality, or it's just like solving a specific problem. And so it's getting to the point where now I have a dream and then I can just talk in English, and all of a sudden I have this application that does this thing for me, that solves various problems. And so we're teaching this at AI Whispers with this, which is in Buenos Aires, where we've got this group of people that I'm basically me, and then actual real developers are teaching everybody how to do all this stuff. And so I was like, okay, about a year ago, it was a puzzle. It was like a challenge. I had to go learn about these technologies and go bring that in and figure out what was going on and like get a blocker and figure out strategies for how to get around that blocker. And then in the last month, it's gotten to the point where it's like, I can't tell whether I'm just getting better at doing it or whether the AI is getting better. And I think this is actually where AI is going to collaboration rather than us just becoming not useful. So, but that's a tangent. So we're going to keep focused on these coding. So I about 2 or 3 months ago, I was like, okay, there's this private tutor element of these AI where it's not coding for me, but it's teaching me about technology. And so as the coding agents have just gotten better and better and better, I'm like, okay, well, how can I bring this into the real world? And so I got this guy from China. I just arrived last week. I still haven't gotten it working yet. I got my Raspberry Pi. I got my ESP32 with a long range antenna. And so those are all computers with chips that do various things. And so I'm learning about these things. And part of it is having the AI code for me in various things. Part of it is me just learning how to connect things and do all these things. And I'm just like tinkering, basically. Where this leads me is like, okay, robotics, where will that fit in, right? Because this basically, what is the difference between this and a robot? Is there a difference?
I mean, somewhat, right? So, like, I can say from the perspective of, let's say, mobile robotics in my experience, right? And using like visual sensing. So I think it's generally like to build like a robot that can sense the environment really well. It's still a lot about both sensors and quite some data processing, right? So like things that you need to build, or like the hardware you need to depend, is a bit more powerful than what you were holding in your hand, right? Than ESP32 or something.
Oh, interesting.
it's still like processing, streams from cameras in a way to navigate, to understand where the obstacles are, where you are located. It still requires just moving a lot of bits of data from all cameras through the system, right? And
So wait,
yeah.
so does that mean are you using the cloud for that, or is that all like, or is it in one robot?
So I would say, like, depending on the application, we can use either like edge only. So in many cases, I mean, good example is that, for example, those professional cleaning machines. So like I'm gonna use the Swiss example. So many times you clean grocery stores with those. And Zurich is a pretty cramped city, so the grocery stores often end up being underground, in like concrete buildings, basically, where you have absolutely no reception. So,
Wow.
like, you're only, I mean, including your mobile phone, right? I really struggle sometimes to check my shopping list if I forget to kind of cache it on my phone. So basically, you need to depend on the edge intelligence because you don't have much choice, right? You cannot like hope that the cleaning personnel will connect it to some Wi-Fi that is maybe there or not. Uh, on the other hand, we do have those cases, right, where we work in factories. You can think of fleets of 10, 20, 100 robots where you want to orchestrate them, you want to talk, like you want them to talk to each other. So there is a natural need for something, right, which is like enabling them to talk to each other and exchanging information about, for example, the environment. And in this case, you have, in a way, two choices, right? Either use something on premise or use the cloud. Uh, Given the type of our customers, most of them go for the on-premise solution just because of the confidentiality, right? So if you think about
Mm.
automotive industry, where they are somewhat careful or very careful about like data from the factory, like new models being, started, not being like accidentally leaking, not being accidentally leaked, right? Then of course they want to keep all data on-prem.
Man, it's so interesting, and I love doing these interviews because it's like, yeah, I can tinker with my things, and then I talk with people who are experts, and they like, you know, bring it out to a bird's eye view of the whole entire thing. The on premise is really interesting because I think what you just said makes me think like right now the only way to do high quality AI is to go into a cloud and do an LLM call through an API. But it feels like based on what you just said, including for people like myself who just value privacy more, like there's no way that LLMs don't just become local, right? Well, actually, there's a good question for you. Like, given your robotics experience and knowing how much data needs to flow through robots, what do you think about software LLMs and like whether those will go local or whether those will stay cloud based?
So I would say like probably like a mix is a balance that we'll see for another bunch of years. I don't think they will go local, even if you assumed, right, that the compute power and efficiency will increase tenfold or 20-fold. That's still like too much power for local. But on the other hand, not all calls can be like depend on the latency of the cloud, right? So especially for robotics, if you have a drone or a mobile robot that needs to decide about an obstacle, let's say, is this a human or is this a box? I don't think we have always time, or we can rely on somewhat not guaranteed latency of the cloud to make this decision, right? So on the other hand, you can think that maybe if you have like 5 seconds to replan your path in the map, maybe that's okay, right? Like you can slow down and wait for the cloud to respond, right? So
Oh,
I think
interesting.
it's a mix, really, right?
Yeah. Okay. Latency. There's a question about FPGAs and what those
Hmm.
do because those are now becoming more sort of talked about on Twitter and various places. So let's go into that. And that solves the latency problem, right? Because what do you use FPGAs? What does an FPGA do for you? FPGA.
Hmm. So actually, like for the main brain of our unit, we are not using an FPGA, but we are using basically like some AI accelerated compute, right? So you can think of different offerings that have not only like a classic ARM CPU, but also some part that accelerates AI in general. But FPGA is basically like a programmable logic let's say microchip, right, or IC, where you can like configure how the gates and inputs and outputs are tied in a very flexible way. So in case of 7 sense, we are using this to shuffle a lot of data from cameras on time into the memory. Let's like generally let's put it like this, and also trigger the cameras the way we like it. But I think overall FPGAs have this like gigantic amount of possibilities these days, right? Because you can program a simple logic circuit on a very simple FPGA up until basically running like a soft CPU. So basically, I know people. I was for a while a bit active in the vintage Macintosh scene, and I know that some people were running like basically like Mac OS from like late 80s on an FPGA simulating the CPU and the entire computer within one chip, which is pretty cool.
Whoa. Whoa. Okay. And were they doing that in order to learn how it works, basically, or for fun?
I think, yeah, a bit of both. I think it's like those that wrote it, right? That was a bit of a learning experience,
Yeah.
right? Because you had to kind of cram the entire kind of motherboard of a computer with many chips into like basically logic definition.
Oh.
And for others, it's a chance of if you don't want like this white box, right, with a CRT screen, like this vintage Macintosh, but you want to play with the old system or games, you can get like a new PCB with an FPGA and a bunch of other circuits that will just connect to your modern screen.
Oh, interesting. And that's really what computers allow us to do is infinite configuration. That's what I've been figuring out. Like now that I'm, it's so crazy with the LLM with this private tutor aspect where it's just like, I deal with this thing. Like I've known what a terminal is for a really long time, but I have no idea, like all those little tiny magic spells that you can do inside of the terminal. Now I just ask this thing, and rather than going through Stack Overflow and trying to find these little random things that, a guy like in the 1980s, 1990s just like went off on his own and did his thing. I now have this thing where I can learn about it. So I'm learning what a computer really is. And then actually this great segue back into robotics, because a robotics is basically just a actuator, something that changes energy from electricity into mechanical mixed with a computer, right? Are there any other really important variables inside of there?
So I think I would say like maybe a definition that often like our professor was using at ETH, which was like called see, think, act cycle. So I think you were talking mostly about act, right? So turning electricity into actuation. But I was personally always more active on the other sides, right? So it was like, for me, it was always interesting, like the sensing part and kind of the reasoning part based on the sensing that only later kind of went into actuation. So like even though I studied robotics and that's my very last state at ETH was at mechanical engineering at the mechanical engineering department, I never really did anything mechanical, at least at work. But I was always like kind of on this perception and reasoning side.
Okay, that's really good because that's basically the part that I missed is that there's an input and there's an output. Well, that's with a computer,
Exactly.
right? You have input and you have output. And the input, what you're talking about, sounds very software based. Well, it sounds like
Exactly.
sensor based and software based. What are the coolest sensors that you've heard of recently? Like I've recently heard that you can put a sense of smell inside of a refrigeration truck to have that input being the sense of smell that things are going bad. Are there anything that's really kind of captured your attention in the last few months in terms of sensors
So I think like maybe somewhat touching my personal projects, but also like work projects are like the multitude of like optical sensors that are coming out to the market and are dirt cheap. So
Yeah.
I'm thinking about like 3D cameras or laser rangefinders, or there are like those tiny chips which are a few dollars, which are like 8x8 range measurement cameras. I mean, that's really impressive, right? Because when we were, let's say, starting to build a company, you could only dream about this, right? And now this is like, a bunch of dollars, right? That is available from DigiKey or someone. So that's really cool.
What was the name of DDQ? What was it?
DigiKey is this global distributor of components. So it's this shop with basically pretty much everything electronics.
How do you spell that? Sorry, I want to make sure I get that one.
Digikey.
Great. Okay, so you got a whole bunch of optical sensors that are really cheap, so how we could talk about anatomy too, because this is like it's very like a robot. Everybody goes to the humanoid robot. I've had various
Hmm.
guests in the past try to like they kind of don't really think that the humanoid robot's the way to go. We'll just have a whole bunch of specialized robots. And but if you have a humanoid robot,
Hmm.
there's that other company we mentioned where it's like they've kind of done the Westworld thing. It's like, well, eventually, it's like, well, what is the difference between a human robot and a human? And that gets into sort of deep philosophical territory we don't need to go into, but we can go there if you want. And there's this I just looked into this, like what is the equivalent of a pixel in the human eye, and
Hmm.
there is no equivalent to the pixel. There's various things. There's like I think it's the rods or the cones, and there's
Hmm.
some sort of equivalency measure there. But if I can look at my eyes and see these various things, what is the equivalent in a robot when there is it optical? I imagine it is optical for the cleaning robots, and like how is that different from our vision?
Yes. So I think both. At least like talking about like what we were doing at Seven Sense,
Yep.
right? Like I think the parallel to the human vision and navigation is actually even closer than that. So indeed, we are using cameras. So we are using multiple cameras. This can be two, but can be up to eight. Uh, I mean, it's just a bit of a robotics convenience, right? We have two eyes just to the front, but it's always nice to add cameras to the back. Why not, right? You don't need to turn your head. Uh, so I mean, still, right? It's a similar vision. So you have like rods and cones in our eyes, and they are very very advanced, right? Like great resolution, super good resolution, grayscale, kind of okay resolution RGB. Uh, like for robot navigation, we can do something similar, right? Like mix the cameras. Like RGB is better for like recognizing objects and stuff like this, so color. While for many things like navigation and recognizing obstacles, grayscale is either equally good or maybe even better, just because it's more light sensitive. But it's we are not finishing here. So we are also in our solution using IMUs, so accelerometers, gyroscopes. So this basically tells us not very precisely about turning rates of the robot and accelerations in all directions. And this is very similar to our inner ear in the human.
Oh,
So
wow.
you can imagine that even if you close your eyes, right, you're not falling down, you're staying upright, and you more or less have this feeling of space. Like if you walk with
Yeah.
your eyes closed for a while, you kind of know where you are walking or in which direction. And the third signal that is also like an obvious choice, right? Is just taking some kind of wheel ticks or wheel encoder data from a mobile robot, right, or a humanoid legs. So basically, if you're able to say it's maybe the wheels are slipping, maybe you're not sure how far the robot is moving, but at least you know, okay, the wheels are turning like this. It's always like kind of a cheap to get a signal, right, that you can also fuse in your kind of sensor fusion machine, basically. So this is similar to basically our body, also depending on the information from the legs, right? Knowing if you're doing a big step or a small step, which is also fused by our brain in this. If your eyes are closed or it's completely dark, you are then using your inner ears and the leg information to
Oh,
know how much you actually move.
whoa. So that's a redundancy that the humans have that you guys have built into the robots that like when the lights are on, I'm using my eyes, a little bit of inner ear, and the sensations for my feet. I close my eyes or it's dark. All of a sudden, my inner ear and my sensations, my proprioception in the feet,
Exactly.
is it interoception as well as is interoception is like it's probably mixed in there a little bit, but well, no, the interoception is probably really well connected with the inner ear. Um, yeah. Do you know anything about that on the human side?
So I'm actually not entirely sure how that works, and I mean I just know like more or less the principle of working of the inner ear, right? Which is like not far from the IMUs. So I think you have like small stones which are moving as you kind of basically move your head, right, or kind of rotate your body. And
Yeah.
I think like the IMU, those like modern micromechanical elements, right, in the IMUs are basically like small forks that deform as you either turn or accelerate in different directions.
Whoa.
So I mean it's not the same, but conceptually, it's not that far apart.
So, what have you learned about the physical world from sensing it and then in programming that into robots? Like, what's the craziest thing you've learned about the? Do you ever have these experiences where you learn something about the way the world really works, and then it reflects in your consciousness, and it's just like almost like sort of like a little mini psychedelic trip with no psychedelics at all necessary? Do you ever have that happen?
Yeah, that's an interesting question. I mean, one thing that came to my mind first is like how self-similar some parts of the world are, right? So we as
Oh,
humans can recognize, let's say, our location perfectly well in the world, or usually, right? But let's say the non-perfect, like say robotics algorithms can often be tricked by places which are looking almost the same but are actually different
oh,
places.
interesting.
So, so we had a bunch of those funny situations when we were starting to develop the system, where suddenly kind of the same shape of a post box on the office building at every entrance kind of triggered the robot to think it's in the wrong location or stuff like this, right? It's like, I mean, these are early stories, but they're kind of funny. Before we actually realized what's happening, it took a while.
And I mean, there's a question about like the solution, but once you said that, I was like, oh, well, do you think the physical world will have to change for these robots? But I imagine the technology should get the perception and all these sensors are just going to get so much better that that's not even a concern.
Yeah.
The so like what how the thing you said about the 8 eyes, where we have 2 human eyes that allow us to see what's in front. It made me kind of really jump very quickly to sort of like the transhumanist world that may or may not be coming, of just essentially like how do we start modifying our own senses, and then with the brain computer interface. Interesting thing about the brain computer interfaces that I've been doing a lot of research on is that so far all it is basically, and you maybe know more than this than I do, but all it is basically uh, it's only giving these guys both the ability to control objects with their mind, which if you're paralyzed is really important. But it also makes them like a millisecond better at playing StarCraft. So like they're just like a little bit faster, which like for me, I'm not really interested in connecting something to my brain, which is owned by a centralized third party with a bunch of stockholders. Like I'm not doing that so I can get a 1 second better improvement on StarCraft. Although yesterday there was we played with anti-gravity, which is Google's new IDE that brings in agentic behavior, and it is very much like playing StarCraft with agents. But that's all sort of aside. Is basically like the so like the brain computer interfaces aren't that like advanced. But as you were talking about the 8 eyes, I was like, well, what does that look like in the sort of the vibe coding, or what is the UI and the UX of interacting with these robots? So the robot has 8 eyes, but then I have a screen where I can see the robot. Well, actually, is it going to be all automated? It's because it's going to be AI using these robots to do various things. But I'm sure we'll build UX and UI to visualize what they're seeing, right? That's what's going to happen. What do you think?
Yeah. So, I mean, returning to this like mom and pop workshop discussion, right? Like, I would assume for those applications, more or less, right? You would depend on like somewhat automated generation of the process, right? So, I think it's like in those cases where maybe you don't have like crazy robotics experts at those locations, you just want people to like define a task like they would define it to a colleague, right?
Yeah, yeah.
Let's say if I would have a workshop and I would need someone to push a cart with some parts from one machine to the other, so it's called like a machine tending application, right? I would say, hey, look, I mean, we have a task like this, right? Here is the cart, here is the machine where you need to pick up parts, you need to load it onto a cart, push 100 meters, and then load into the other machine, right? And I would hope that robot figures it out. In those like very large spaces, right? Especially very demanding applications right now with like a very well-defined like frequency of production, like automotive.
Yeah.
There you kind of depend still on the UI and like a proper, human definition of like what the robots do and how they work, because every second counts. You depend on many like a bit of ephemeric factors from outside, like how fast you want to be, how safe you want to be, are forklifts crossing the path, what's the somewhat delay of some machines or doors or whatever. So it's really like, as of today, it's in big parts like manually defined those workflows. But I believe, right, this will change as well.
Yeah, and now I've got a much better understanding of robotics. And this is the hardest thing for me to understand about both robotics and manufacturing, is that it's like the enterprise. it's like studying the enterprise rather than studying startups. Well, if I can just go find the people who started a startup. I can go talk to them, and I can understand that startup, right? I can understand where they. But if you ask me to understand IBM or Apple or all, it takes like a lifetime to understand that thing. And then so it's like manufacturing and robotics. It's the same thing, and it all happens like it's not something that consumers see. It's like you have to get really, really nerdy, really, really focused, and like go to ASML, like to go take a tour of ASML. It's like that's really random. Like it has become more popular over the last 10 years. And like ASML, like that's only become popular because of how important the chips are. But there's this whole world, robotics and manufacturing. With that being said, like I guess you went to ETH, and so how did you end up in this field?
So, like I went to ETH to like for master study, so like second stage degree, right? So I studied first in Poland, and at some point I realized, okay, I really want to do robotics. I would like to find some university which is really strong in it.
Wait, but why did you get into that really robotics? What about it was? Oh, it's hard to answer those questions, right? Because it's like I just wanted to do it, right?
Yeah. I mean, I think what really like was floating my boat, right? Like was a connection of software and hardware, and I was always a bit of a tinkerer by heart. On the other hand, I also like writing software and a bit of like robotics, like math, right? So it felt like going hardcore control engineering was a bit too much math and too little of like things you can touch for me. On the other hand, mechanical engineering was a bit too little algorithms and software, right? So robotics is just like somewhat immediate reward almost like field, right? Where very quickly you can build something, get it tested, and have fun with it, especially as a student.
Okay, so and I want to hear like how you transitioned into the field itself, but before that, now I've got a really good question that's been going in the back of my mind, which is, so we've got AI whispers. As I showed you, I've got all these things that I'm building with this is going to be a voice AI agent, so I can hook this up to something called VOPI, and then it's got 4 microphones, and I can basically have agentic behavior that's better than Alexa if what's in my mind is true. And so these are my first types of projects. I should probably start with robotics after this one. What is your suggestion for the best learning experience? It may be something that is like possible down in Argentina. that's a really hard constraint to get it in Argentina. But like something that's somewhat cheap that I can get other people to build as well along with me. What's like a really simple project basically?
So like what's I think really shaped me in many ways were like projects that happened both in Poland and in Switzerland here during my studies, which were using like relatively cheap like small educational mobile robots, like this size, which you could control from outside from some Raspberry Pi or Arduino or whatever, and hook up a bit of sensing to it, right? So they are like kind of slow and make funny noises, and you're like, okay, that's just a toy robot. But to be honest, like if you hook up like some kind of camera to it, or maybe even like a depth camera, like those Intel RealSense cameras or stuff like this, you can actually like face challenges somewhat similar to what humanoid robot builders are facing to solve the navigation, right? Or exactly. I mean, it looks a bit lame, but in the end, it's really, you're like doing exactly the same and super fun. So we had a course when you had to, navigate through some labyrinth, or you were dropping the robot in some unknown spot within some kind of space, and you had to localize using a particle filter. Like that was like kind of pre-AI times, right? But it was like super exciting, and you could like test a lot of, how to approach a mobile robotics problem using this setup, which is not that expensive.
Okay, yeah, no, that's definitely what I'm going to do. I'm going to get a mobile robot. Is that like on what are the options? Like there's wheels. I imagine there's not bipedal. You weren't doing bipedal things, right?
No, we were using like a 2-wheeled like little robot. I think there was even like a project from Swiss universities to make an educational robot. I think it was called Timio or something like this. But I'm sure these days, right, like 10 years after, you can basically get it from everywhere.
I've seen them on Amazon. I just didn't connect it that's the thing that I should do. What is a particle filter?
So I mean, I really like this concept, to be honest. So
Mm.
the idea is that if you need to localize a robot within like some kind of bound space, you first assume that it can be kind of anywhere, and you throw a number of hypothetical locations, let's say 1000, all across this space. And then you start moving somewhat randomly or in a arbitrary direction, and then you're like checking which of those particles moving as you move like still fit your definition of the world.
Oh,
So let's say if
world model.
some particles observe the world that you're observing to see, then they become like higher probability. If some particles shouldn't observe the wall that you're seeing, then you know they are less likely, right? And at some point, your belief converges from this multimodal distribution into basically one particle or maybe a few that are the most probable. And I think it's a great concept to teach probability.
That's really interesting. So it is like a world model, and this is actually a great opening for the question that goes back into sort of something I'm a little bit more familiar with, which is world models. Like Jan LeCun doesn't like LLMs because they aren't world models. And I think he's right, but I also think he's wrong, because I think we can build a world model on top of this base layer of LLMs. So you have the LLMs doing this thing, and then you have the world models sort of like taking that LLM kernel and then building on top of it. Do you agree? Do you disagree? And totally fine if you want to disagree.
I think that makes sense, right? So like in my mind, right, like having a decent world model is very important, especially for physical AI and physical robotics, right? So in many ways, what my work has been going into and is going into is basically how to build a good representation of the world that helps you then take smart actions within it, right? So yes, you can use LLMs for many things, right? And we know they are super helpful. But in the end, right, like combining this reasoning together with like a very good understanding of what's around you, let's say in case of mobile robotics, right, of this spatial representation, is really like making a total difference, right?
Okay, that's really cool. So there's two really important parts of the world model you just said, which is reasoning and knowing where you are in space time, right? Those are the two important parts. And a current LLM doesn't do that at all. I mean, they're giving it reasoning, and it does have multimodal where it can go see, but those things aren't foundational for what the LLM is, right? Did I get that right?
Yes.
Yeah.
I would agree with that, yeah. Even though, I mean, I can say, because actually, like during my PhD, I was working a lot on the topic of like how to localize a robot in space. And or a camera, right? That sometimes wasn't even a robot; it was really like a mobile device. And this has progressed like tremendously, right? So when I was starting, it was really like there was no AI in it. You were like just like doing a bit of pattern matching or descriptor matching, as it was called, or it is called. And it was like prone to many types of failures, right? Right now, like where this is going is really like making like an end-to-end model where you kind of teach it the representation of the world, which is maybe not really easily interpretable by a human, and then you can like throw data into this model, right, and get an answer where you are. So it's really becoming like way more advanced, but a bit more black boxy compared to like what it was in 2018, maybe in some ways.
Why is it getting more black boxy?
Just because the representation, right? Like you cannot really get a very clear picture, like how the answer has been derived based on your input, right? So let's say in this traditional models or only partial AI, partial computer geometry, you kind of know, okay, AI matched this parts of this image to this parts in the map, so I know if it made a mistake, you know, okay. Like returning to the postbox mention that I did some time ago, right? It's like if a mailbox is confusing to the robot, you will see it localized against the wrong mailbox, right? But I mean, in maybe those more end-to-end models, this is much harder to do. It's much harder to interpret, which, I mean, I would say generally there are like people pretty concerned about this lack of interpretability for physical AI, right? Because here we are talking also about safety for humans, for workers, right? It's not like a fun conversational partner, right? You might be controlling a car or a heavy robot, right?
Well, there's a bunch of questions here and I want to get one out before I forget it, which is the self-driving cars. I imagine lose their interpretability, but then also within LLMs are not interpretable either. So we're getting into like very, very, very strong black boxes on all levels. Do you know self-driving cars? Do they have lack of interpretability and that same problem? Is that the event thing you're talking about?
Yeah, I think I mean generally I would say like mobile robot navigation is like conceptually right, like not so far from autonomous driving, right? So we have similar modules. Like of course we have a bit of a, I would say, still simpler problem, right? So you don't have like that much speed. You have a bit more controlled conditions. You don't have random traffic and drivers or pedestrians that might do anything. But still, right? It's like block by block, it's kind of similar. And I think how you solve this problem right now is really you take those black box models, which are sometimes the best, but you build a bit of a safety guards around them, right? So you let the AI do the AI things, but in the end, if your radar or LiDAR or cameras see like an obstacle incoming very quickly, you just hit the brakes and just like basically bypass the whole AI magic, right? And in industrial robotics, it's actually similar. So you also have safety sensors and of course, we hope we never have to hit the brakes this way, right? But whenever the safety sensor sees an obstacle, you basically hit the brakes no matter what happens in this kind of deeper reasoning brain, right?
Yep. That's really...
Maybe this can be compared to reflexes of a human, right?
Okay, this is really interesting territory because that's the same thing that's going on with LLMs, which is that it's a black box. We don't have interpretability. Anthropic is the sort of the farthest ahead of doing this interpretability, and I think they're doing exactly what you just said, which is they test it under conditions where they sandbox it inside of a container, that it can't escape. There's no way to escape, and so they can do all these strange things with it to kind of evaluate it, not on the inner workings of it, but evaluate it on the outer workings of it. This is so interesting because it gets into territory of the robot consciousness, and I'm not a believer that it is conscious. I believe it's a next token predictor, right? It's just an emergent thing. We could talk about how maybe consciousness is the same thing, where it's like, well, it's not like our appearance of consciousness is just some sort of evolutionary thing. It's like similar to a token predictor. But ultimately, I think there's a very, very strong difference between our intelligence and machine intelligence. And I don't think it's kind of getting breached anytime soon. But there are other people who disagree with me. And if they are right, and strangely, a lot of them work at Anthropic, and which makes it even stranger because they're both the people who believe that they've awoken some sort of a consciousness and are testing it the best. Maybe actually that's why. And so they're bounding this thing and they're testing it and probing it. But what if it's so conscious and so smart, it's just waiting, it's just waiting until like, how do we know? The only way we'll know if it leaves some sort of trace. But if it's so smart that it can outsmart us, then it's not going to leave a trace, right? Like, yeah.
Yeah. Yeah, it's a fair point, right? Like, I mean, really working with this physical AI and especially robots and knowing, like how many parallels are between like what we are building and, for example, humanoid robots. I mean, I still believe we are far from this, right? I still think like those AI models or like this AI consciousness, if it exists, it's still kind of closed in a container, right? And it's like well safeguarded by either mechanical limitations or safety limitations, right? But I mean, of course, right? We are in 2020, end of 2025, right? It's like looking at how much the world has changed in terms of machine intelligence in the last 5 or 10 years. I mean, this will get different for sure, right? It's like, I mean, one example being right now in industrial robotics, you cannot really use anything AI or anything even machine learning for safety. It has to be like a really primitive deterministic system saying there is an obstacle or no obstacle.
Whoa.
Like there is no way kind of around it. But, right, like there are like voices about how can we make like leverage all the progress made by AI to actually build better safety sensors, right? But when the certification bodies say, oh, whoa, we will never approve anything, right? Which is not perfectly deterministic.
Whoa.
So it's pretty interesting, huh?
The safety bodies are doing this. Let's go into that. So there's industrial robotics and they're probably at car companies. They're at large regulated industries that are probably regulated in every single country. Is any country like that is also advanced enough? No, there's no country that's advanced enough with large industrial scale robots who's just like, well, let's experiment. Have you heard of it?
I would say China is a bit
China,
more
China doesn't care about safety. Interesting. Okay,
chilled about this.
so yeah, it's go.
So it's not like the robots are unsafe, but they don't have such stringent regulations like I mostly know Europe and the US, right? And here, I think in both cases you need to have this like separate safety system bypassing basically the entire, let's call it, controller.
Yeah, but can you explain what you meant by that? By passing the entire controller, what does that mean?
Yeah. So it basically means that there is a safety sensor, which is like outputting like a binary information about like should stop, for example, or not. And then this signal goes directly to the low level actuation of the, for example, wheels or whatever, or like the robotic arm, which is basically like a kill switch or a brake switch, right? So whatever our 7sense thinks does, right, when the safety triggers,
interesting,
like the robot just like hits the brakes full power.
Oh, that's cool.
So this is a bit of a safeguard, right? Also, like it's very convenient for us, obviously.
Why is it so? You built a sandbox, or well, they built a sandbox, and you can operate within this sandbox, and then immediately an off switch happens, then it shuts off, basically.
Yeah, exactly. So I mean, especially building, a startup company, like not having the liability for safety, that's a very convenient thing.
Are there any who among all the in Europe or the U.S. and maybe it goes state by state in the U.S. But like what and I guess Europe now has the sort of transnational boundary upon it. So I want to talk about regulation and like which country or which municipality or the U.S. versus Europe who is thinking the most clearly about regulation or like what you just said, like that was done by a regulatory body, right? Like it said, like there's this part of the machine that can't be touched. Here's this other part of the machine. Go fool around with that. Can you talk more about the regulation side of that?
Mm-hmm. So in Europe, it's completely harmonized across all member states and also non-member states like Switzerland of the EU, right? So there is basically something which is called Machinery Directive, which defines basically the safety of machines. So it's a legal act which then, depending on the application pools and our legal acts, it's like a fairly complex network of documents. But in the end, it defines requirements for providing safety of general machines, right? So not only mobile robots, but also, any types like a chainsaw or some whatever metal press at the factory or whatever. And this basically calls for specific safety levels, which in turn with specific error rates, which in turns are granted by those regulatory bodies or like regulatory agencies. And those are like, I mean, I'm not sure if we should say fairly conservative, right? But they definitely want these systems to be deterministic as of today. And actually in the US, it looks very, very similar. So there are like different institutions, but kind of the legal framework, I think it's the same. So it doesn't really depend on the state or municipality. It's basically
interesting. That's
Europe plus the US, it's pretty much the same.
It's so interesting in my country because, and now I'm down in Argentina. We could talk about Latin America too, and let me know if you have to go at the hour. But in my country, in the United States, we've got all these different states, and the way the Constitution was set up is that we have a balance: the federal government versus the state government. But with the rise of big science and with the big rise of these problems that we're talking about, then the federal government became this sort of like, okay, well, it's just making the decision. You states implement the decision. And that's interesting, but I also think there's something to be said about different ways of testing the system, which like federalism, which was designed to do. That brings me down to Latin America, which is interesting because Latin America doesn't have the type, I mean, Argentina has a lot of people who are really well educated. They have satellite, they have nuclear power, they have like the late 19th century foundation of an industrialized economy, but it just didn't make it, or it like made it, but really poorly compared to both Europe and the United States. But it's there. Brazil is kind of like an expanding country where Brazil didn't really have it except in the south, and has all these issues, but they're sort of farther along than Argentina at the moment. But what both Brazil and Argentina share is a lack of a strong federal presence, national government. So there's a lot of
Hmm.
like leeway to do various things, and I'm just so interested like to see if it works for like because most of the Argentines who I know who have started businesses here like they're the best business people because they've operated under conditions that no other country in the world has operated under, just crazy capital controls, crazy hyperinflation, all these really insane stuff.
Yeah.
So it seems like a total nightmare. Could be changing, could not be changing. But at the moment, we're just doing sort of this educational thing, which I think is really fun. And I would love to invite you to, once I've actually gone and figured it out, maybe you could teach us how to do it via Zoom or something like that, how to get our feet into robotics.
Of course.
Yeah. Anything interesting spark for you in that?
Yeah, so I mean, when you were talking about like this federalistic or not countries, right? Like I was thinking, I mean, first of all, like Poland, for example, is completely like centralized, right?
Oh,
So,
interesting.
like, given how the country is like was kind of reshuffled and mixed up after the Second World War, there is no notion of, I mean, there are like regions, of course, right, and regional governments, but such legislation always comes from Warsaw, from the capital.
Mm.
On the other hand, like Switzerland is a
Right.
is
Yeah,
a
plus,
is
yeah,
a federalistic
yeah.
country, right? And I feel like, for example, Zurich, right, which is like a region, like the canton of Zurich is basically a region of the city of Zurich and some lands around it. I think here, I think I'm not entirely sure, but like some of those like robotics challenges or legislatory challenges are actually somewhat supported here, right? Just because like there is like, I mean, clear understanding that if you want to keep Switzerland like growing and somewhat flourishing, right, you need high tech. And so some of the companies working on different mobile robots, like there is Anybotics, right, doing like quadrupeds. There's River, which recently tried delivering together with like one of the online delivery companies
Mm.
here in Zurich. I think they had some legislatory issues, but also I can imagine that the local government of Zurich, right, is way more ready to find like good balance of also promoting innovation compared to like federal government somewhere far away, right? So
Mm.
maybe this local function also has benefits, right? If robotics or if the growth of technology is actually aligned with some of the interest of this local region or canton or
Hmm. It gets in.
state.
It gets into conversations I've been having a lot about. There's this book called Sovereign Individual, and what my actually most recent guest Joe Wilkinson was like, no, it won't happen first with sovereign individuals. It'll happen first with sovereign countries. So like countries are going to become more sovereign, and I think that's right. I think that as the United States kind of relinquishes its role as this sort of arsenal of democracy, which is always a funny term, but so as they sort of relinquish this role, which they recently did, I think a week ago, the U.S. government put out a
Yeah,
foreign policy that they're basically were going back to Monroe Doctrine 2.0, and and so I think countries are just going to be able to build up their own, and as it gets easier with AI, build up their own high tech industries. And I think a lot of countries are going to be able to do it, right? And they might even follow the United States 1940s path of just like we're going to centralize it. We're going to, from the federal government, we're going to create high tech. We're going to invest a lot of money and we're just going to get it done. I think that might happen. What do you
of
think?
course. Yeah, I agree. So I mean, first of all, this change of the U.S., right? Like that's quite a shocker for like Central Eastern Europe, right? Like
Well,
because I mean,
interesting.
in some ways, U.S. was a bit of a one of the main warrants of like
Whoa.
feeling safe in this
Yeah.
region, right?
Whoa.
Rightly or not, I
Yeah.
think that's for everyone to decide.
Whoa.
But clearly, like it's a shock,
Yeah.
right? And I can already see, right, that in Europe or Poland or like there is a bit of unfortunately driven by kind of the defense industry, right? But there is a drive of like building high tech locally, right? And I think we've learned from the experiences of the war in the Ukraine, right? How important the drone technology, like basically like the battlefield has changed completely, right? And many of the technologies that are making a difference are actually way more attainable by like somewhat a talented group of engineers compared to building tanks, right? So I think
Mm-hmm.
that the rules of the game have changed very much.
Drones are built by small teams of engineers. Like that's a factory of a drone, basically.
I mean, like from what I understood or heard, for example, from the Ukraine, right? Like
Yeah,
often, like perfectly, like basically consumer drones are like
yeah,
re-equipped by
yeah.
advanced sensing technology, for example, by a group of somewhat experienced roboticists, right, that know what they are doing, right? So, like, it is hard to imagine this in this super professionalized defense industry world from 10 years ago, right?
Whoa. That means the engineers do become warriors. That I've been thinking as engineers as warriors for a while, just because of um, the sort of changes in our environment in terms of IT and software. But now it's like, oh no, it's the whole. It's going to be engineers are the ones who are going to be creating the technology because they have the knowledge. So knowledge really does become the main thing for warfare. Yep.
You know what really shocked me? Have you seen maybe those pictures of like fiber optics in the
Yep.
fields in the Ukraine?
Yep.
That's that's basically a good example, right? Like probably like in a bunch of months, like the switch from like wireless transmission to basically fiber optic control just happened. I mean, I
Emergent.
guess just like emerging technology. Just quickly, someone thought, okay, what can we do to actually like keep the communication running, right? That's for me, that's like insane pace, basically.
And that's the whole history of technology has been motivated by warfare. So it's nothing new, but except for the pace of change, which is very very accurate, and it's only going to speed up. Um, but
Yes.
okay, well, thank you so much for coming on the show. And how are you
Yeah.
writing about this? Are you producing anything for people to follow what you're doing?
Not very actively at the moment, to be honest. I always have this thought of, let's say, sharing both my projects and thoughts more actively. So I have like some very minimalistic website, which you can find on Google. But I would like to share more of the projects. Right now, I'm like super busy with the family and kids, and barely have time to actually follow up on my projects, not only write about it, but I really do plan to return to it and actually share a bit more.
Cool. Well, anytime you want to come on for another podcast, let me know. Thank you so much.
Of course. Thanks so much. Thank you.